So in this video, I'm going to talk about higher order derivatives. Now, the important thing to get out of this first video is what is a higher order derivative, or at least how to write what a higher order derivative is. So in the past, we've talked about how taking a derivative is a process called differentiation. Okay? And since this is a process, this process can be repeated multiple times, or as many times as we need to. So let's, for instance, say we have an original function and we can call it either f of x or we can call it y. And if I take its first derivative, we would write that as f prime of x with an apostrophe, or we could say it's y prime, or we could also write it as dy dx. And in this case, the operator, the way we write this is we say that d over dx is the operation of differentiation. That's what's telling me to take the derivative just as much as a plus or a minus sign is going to tell me to add or subtract. So the thing is if I want to do it twice, well, all I'm going to do is essentially say d second over dx to the second. So I'm saying, do the d dx twice. The way I would write this as a function is I would say it's f double prime of x. So I put two apostrophes on it instead of one. We could do the same thing with y, so we could say y double prime, with two apostrophes, or we could say d to the second y over dx to the second. If I do the third derivative, it's going to follow the same kind of pattern, so it'll be d to the third over dx to the third, and we can write f triple prime of x and y with three apostrophes. Now, the special one comes in when I try to do the fourth derivative or anything higher than the fourth derivative. So I'm still going to write the actual operator, the d to the fourth, dx to the fourth, the same way. But instead of putting four apostrophes, most people will write it as f with a 4 in parentheses as an exponent. Now, recognize that this is very different than saying f to the fourth. This is not the same thing. The parentheses are trying to hint to me that this is actually a derivative and not, multiplying it by itself 4 times. So again, we would say it's y to the 4 in parentheses, saying fourth derivative. And I could write it as d to the fourth y over dx to the fourth. So that's what generally we do if we have anything bigger than 3, is we would write whatever that number is in parentheses to try to let me know how many times I need to take that derivative. To keep going, I want to talk about some special names, and these are specifically about physics problems because we see a lot of physics problems when we talk about calculus. The original function is typically, for physics problems, going to either be the position function or it could also be displacement. Now, these things are similar, but they're not exactly the same. For example, if I were to talk about a vehicle and its position, we could talk about, where its physical location is over time. So, what road it's on, how far it is from different locations, etc., etc. So we can figure out the vehicle's exact location using this position function. However, displacement is more of trying to say how far the vehicle has traveled from its starting point. So we would talk about, a vehicle starting from your house and how far has it gone from there. And so displacement is more of talking about a change in distance, where position is more of talking about location. But again, they're very similar and they both represent that original function. From there, we'll talk about the first derivative, which is also called velocity or speed. Now, again, these are related, but they're not exactly the same thing. Velocity could be positive or negative, whereas speed cannot. What I mean by that is speed is actually the absolute value of the velocity. So, for example, if you decided to take your car, put it in reverse, and press on the accelerator, press on the gas pedal, your speedometer is going to read a positive speed, not a negative speed. Whereas if you were to talk about its velocity, you're going backwards, so your velocity is negative, whereas forwards, your velocity would be positive. For the second derivative, that is typically referred to as the acceleration. And again, that's positive or negative. It's telling me how quickly I'm having a change in velocity or how slowly there's a change in velocity. It could be positive or negative. For third derivative, it is also called the jerk. This is not typically as important as I would say these first two are. These first two are very important. Velocity and acceleration are very important. Jerk, not so much. And then the ones after these, and I'll just share with these with you because they're kind of fun. The fourth derivative is called snap. The fifth derivative is called crackle, and the sixth derivative is called pop. But again, the first two are the really important ones, the velocity and acceleration. Those are important. Hopefully this helps you guys understand a little bit about the idea of what higher order derivatives are. Again, we're just talking about the idea of taking the derivative repeatedly, if performing this differentiation over multiple attempts. I'll see you guys in the next video. Let me know if you have any questions.